Hello everyone. This is just going to be a really quick video because I recently had a commenter ask me if I believe that calculators were wrong because of the way that they handle the equations of 60 divided by 5 parentheses 7 minus 5. And I responded that yes, of course they are incorrect. The reason why is calculators are programmed by computer scientists, not typically by mathematicians. And computer science majors are not expected to know the intricacies of mathematics the way that a math major ought to know them. And so most computer science majors are going to be basing everything on PEMDAS, completely on PEMDAS. And the reality is when you put in information into a calculator, it doesn't know how to parse out that information. So I'm just going to do a couple of things really quick. Let me just take this really quick to show you. If you go into Google and you actually search for this equation and hit enter, what it comes up with is it doesn't calculate this, it converts it to this. And you can see it puts parentheses around 1 over 5, so it takes that divisor as if it's saying 1 over 5. And then it's saying there's a multiplication that doesn't exist here. It's inserting that multiplication, and then it's saying that 7 minus 5 is this quantity. So it is converting this to that. That's the only way that it can solve these. So it doesn't even know how to handle this context. But what I wanted to do is actually look at Wolfram Alpha as well, because of course it's going to do the same basic thing that we saw before. It converts 1 divided by 5 to 1 over 5 and does that. Now the question is, why does it do that? I have here all possible operations here from basic mathematics with 1 plus 5 parentheses 7 minus 5, and we're saying that's equal to 1 plus 35 minus 25. And then we do the subtraction, then we do multiplication, which is represented here by the asterisk, and then we finally end with division. So if we just copy all of this in and come here, and we just ask, what does this give us? Then as you can see, Wolfram Alpha says it's true, 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 and then suddenly false. Why is division false? When it's the exact same format as everything else, and it's saying, yep, those are all true, but now suddenly, with division only, it is false. And the reason why is because it's using the same rules of PEMDAS here. It's not treating this as if it's distributive in any way when you have the 5 parentheses 7 minus 5. If it solved for that in the distributive sense, as I showed in my last video, you would get consistent answers. They would all say true, 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 and true. There is something fundamentally wrong with a system that takes the same data in the same format and spits out a different answer when you're dealing with both sides of an equality. And you're doing the same operation on both sides of the equality. When you do that same operation on both sides and suddenly you're getting an answer that it says is false, something is wrong with the algorithm that you're using, because mathematics tells you that if you do the same operation to both sides of the equation, you must get the same answer. And very clearly, we did the same operation on both sides of the equation throughout. It works for these three. It doesn't work for that last one. That is something that the proponents of PEMDAS need to explain. You don't get away with this for free. You have to establish why we must take your method that gives a false answer for doing the same operation on both sides of an equality. That's a tough nut to crack, but that's your nut to crack, not mine. Hello everyone, and I just uploaded this video yesterday, but I went ahead and made it unlisted today, and I'm re-uploading a different version of it to add this addendum. Now, the original version only had 6 views so far and no comments, so we're not really missing anything by me taking that one down and adding this. We're actually gaining a lot by me adding this. Now, this addendum is brought to you by the fact that I read a different comment from a person with the name of C. Vis Pacem Parabellum, or C. Vis. I'm not sure how they pronounce that Latin. It could be Church Latin. It could be Ancient Latin, for all I know. The good news, Latin is a dead language, so it doesn't matter how we pronounce it, right? No big deal there. But here's the thing. They had suggested typing in certain things within Google, kind of like I did at the beginning of this video. But I wanted to look at this in Wolfram Alpha, and particularly I wanted to see how Wolfram Alpha handles algebraic multiplication. And what do I mean by that? I mean, when you have variables, you can put them next to each other. So we can say AB is the same thing as A times B. And we put that into Wolfram Alpha, and look at that. Sure enough, AB equals AB. Amazing. So A times B is treated as AB. That's exactly what you would expect from a program that's interpreting algebraic equations. What happens if we change this to, say, a parentheses like that? Now, it should be the same thing, shouldn't it? And you can see it basically is. It does do different things with it down here, but it is saying that this is the same value. It still is going to be an equality. It's not popping up that anything is false. But if we do 1 over A times B, and we do 1 over A parentheses B, what happens with that? Wolfram alpha should, in order to be consistent, treat the second one as 1 over A parentheses B, which puts the parentheses, the multiplication outside, and it should be the same thing as B over A. So let's just see what it gives us. And we hit enter. It does a few things, and it comes back saying that these things are equal to each other. And it would say AB over A parentheses B equals 1. And so we can see that it's saying these two are equal to each other because when you divide one by the other, you get 1. So it's the same thing as what they wrote here in a different format. So remember, whenever an equation equals 1 from this, then they're saying that is an identity. That when you divide x by y and the answer is 1, then x equals y at that point. With that in mind, let's leverage the power of Wolfram alpha because we can put in an interesting thing. Let's say B equals, for no reason, let's say 7 minus 5. We want to say B equals 7 minus 5. What does that get us? Does this mess up anything? And you can see, no. In fact, it lets us know down here, 2A is A parentheses 2, it equals 1. It is saying that 1 over AB and 1 over A parentheses B is identical when you put in 7 minus 5 as your B. So let's just go ahead and add A equals 5 for no reason whatsoever at all. And we do that search, and look at that. It's resulting in 10 over 5 parentheses 2 equals 1. So when you substitute the values in, it treats this as equalities, going from one to the other. So it does treat this, when you add this information in, as equalities. So algebraically, it solves these exactly the way that I say you should solve them overall. So yeah, that brings up to mind the question, why is it that algebraically it solves this correctly? When we put it into this format and we put in those variables, it solves it correctly. But why doesn't it do it when these are numbers instead of letters? That's a good question, isn't it? That's one that Wolfram Alpha and other people who are using this method need to understand. So there you go. As I said at the end of the first part of this, that's a tough nut to crack, but it's not my nut to crack, that's your nut to crack. So have at it, get to it. I'm curious as to what you'll find out. All right, everybody have a wonderful day and peace out.